Hi, and welcome back to another episode of Starburst TV. Today's topic is really interesting. They're always interesting, but this one I got really excited about. We're talking about game theory, and it's a topic that anyone, whether you're a kind of advanced machine learning expert or just a new data scientist or someone that's interested in data science, it's a topic you may have come across as a way to do or as a way to look at data analytics for very specific problems. I'm delighted to have on the show today Gerardo Parrello from Globo. And this is something he is very passionate about. And as you'll hear once we get into the show, he's got a lot of different ideas, not just for how we use and apply game theory to analytics, but how we might apply game theory in that concept of that decision making, that decision framework to the day-to-day problems that a data engineer is dealing with. So excited to jump into it. Welcome to the show, Gerardo.
Hello, Ren. How are you doing? Very
Doing
excited to
good,
be
doing
here.
good. We said we were going to do the show in Spanish, and so, we'll do it in English, but maybe we'll mix in some Spanish for the Spanish
We
audience.
can we can change like as we go, like maybe some Italian in between, like French, whatever you want. Not really, not really.
¿Cómo se dice game theory en français? I don't know.
I don't know.
Is there a Spanish word for game theory? ¿Cómo se dice game
Teoría
theory?
de juegos.
El juego de no.
Teoría de juegos.
Perfecto. Fácil. Well, let's start with just a definition of game theory for anyone out in the audience that maybe has a different understanding or has always heard the word but isn't really sure what it is. We're not talking about actual games here. I'll start because I'm going to give the wrong answer and then you're going to correct me, right? So it's always good to start with that. Let the non-expert give his understanding, right? So when you first brought the topic forward, I went and I rewatched A Beautiful Mind, right? I was like, all right, I'm going to get everything I want. I cheated, right? That's the cheating way to do it. Go watch a movie, right? Don't read the book, go watch a movie. And so they talk about Nash equilibrium and the whole story between kind of Nash's journey to invent, which he didn't invent this notion of game theory. It was an economic theory that I think dates back to the early
John von
1900s.
Neumann and the war, and yeah.
But he brought a new way of thinking to this economic theory, this game theory that said, hold on a second, this is a multiplayer environment. And so in layman's terms, my understanding is when you're dealing in a multiplayer environment, right? You can think about a chess game, but you can also think about a business environment where you're competing with a lot of different players. And in that multiplayer environment, you're worried about pricing, you're worried about supply chain. There's a lot of things you have to think and balance, right? Certainly from a global perspective, you're doing the same day in, day out. If you're Amazon, you're doing the same thing. If you're any big corporation, you're dealing in a very competitive environment, trying to make pricing decisions, trying to make supply chain decisions, trying to make customer decisions. And at the end of the day, you're trying to do so in a competitive manner. But when you look at that entire matrix of all the decisions you have to make and how it affects other players and what they're going to do if you do this and how that ultimately affects the outcomes, it's a complex environment. Game theory simply provides you a framework. And if you're using analytics and algorithms to do it, it gives you an AI-driven framework to think about what the best outcomes or what the best decisions might be. And so to me, that's fascinating. Now, there's my non-data science explanation. Or where did I get it wrong? And hopefully I got some parts right.
It's mostly right, but it's just since it's mathematics, it's a bit more abstract and more simplified because mathematicians want to simplify everything, really. And what you think about big environments, which are a lot of players, it doesn't necessarily have to be that way. It can be a game of chess in which two players are playing, and then the movements that you do affect my outcome, and the movements I do affect your outcome. And essentially, game theory is the study of the behavior in such environments in which you have different agents interacting, and I don't have an outcome that is independent of your decisions. You don't have an outcome that is independent of my decisions. And that's it. As simple as it can get. It's very abstract. So since it's so abstract, it applies to mostly everything. The main exponent of that is a prisoner's dilemma, which is beautifully explained in that movie that you saw when they are dancing, right? I remember there was they're trying to get the girl, and if they all are trying to get the same girl, no one gets the girl. But then he suddenly has this idea: what if all of us get into an agreement and we don't go chasing that girl, but we go with the other girls? And that's when this is my brilliant idea. Then he writes a thesis.
Yeah.
I think it was a 22-page thesis, and that earned him the Nobel Prize in economics. By standards of thesis, that's a very short thesis. This man was totally a genius.
That's genius. I think, yeah, that's kind of the cool moment in the movie where it comes to him, so to speak. But I want to pull one specific thing out there because I think it's going to carry forward throughout the conversation today. This idea that when you're working in a tied ecosystem, right? The game that game is the ecosystem, right? You're working with a set of players. You're all tied into this framework or this government or this ecosystem. You can't jump out of it. You're in it already, right? And any decision you
Yeah.
make affects them. Any decisions they make affects you. That's the dilemma that you're trying to deal with.
Yeah.
Another dilemma people talk about often when they're talking about game theories, popular one, they talk about this prisoner's dilemma, which is, I think, a little bit different. And maybe some people may not be able to apply it to business, but I think it resonates to me. It's this idea you got two prisoners, and I won't give the 10-minute explanation. I'll give the 2-minute one, but you got two prisoners who have an opportunity to shorten their jail time. And if one prisoner essentially rats on the other prisoner, then he can get a shorter jail time. And the other one stays longer. If they both rat on each other, then they both stay longer, right? And so the only way that one person wins is if only one person rats out the other one, so to speak. And so what do? Do I, call out my friend and hope that he doesn't call out me? Do I stay quiet? If they both stay quiet, they both get a shorter sentence, but not the shortest.
Yes.
And so that's a dilemma. The other interesting piece about that dilemma is they're separated, right? It's a non-cooperative environment in the sense that they're not talking to each other, right? They can't get together.
That's necessary for the dilemma. Yeah. Well, you already mentioned the question, what do I do? Which is essentially the study of game theories. And you are touching on the notion of the Nash equilibrium. The Nash equilibrium basically is what's the solution that the game will arrive to, if there is any, when we develop it, right? And you said, okay, what do I do? And that why do I do question is, okay, what do I do if the other player takes this decision? What do I do if the other player takes the other decision? So to formalize the game is, there are two suspects that have been apprehended by the police, and it's sure that they have committed a crime, but there's not enough evidence. And so they're separated into rooms and they are interrogated. And the police tell them that they have two options. They can stay silent or they can confess. And in so confessing, they confess for both of them. Yeah. So they know they go together to do the crime. It's just that, hey, I did the crime and so did my partner. So you're sitting in a room being interrogated and you think, okay, these are my options. And the other person has the same options. What should I do, player one, if you, Adrian, stay silent? So to understand that, then you have to think, okay, what are the rewards and the costs of each decision? And you say, okay, the police has said, if both of you stay silent, both of you will go to prison for 1 year. We don't have enough evidence, but we can charge you with something else that will stick. If one of you confesses and the other doesn't, then one that stays silent will go to jail for 10 years, and the ones that rats gets free. If both of you incriminate each other, both of you get 5 years. And so you think, okay, what should I do? Well, in the situation that you stay silent and I stay silent, I go to jail for 1 year. And if you stay silent and I confess, I get a free card and you go to jail. And I'm looking for my reward only. So I will naturally choose to confess and rat out, because it's better to not go to jail than it is to go to jail for 1 year. And then I do the same analysis for the other option. If you confess and rat me out and I stay silent, I go to jail for 10 years. And if you confess and I confess, I go to jail for 5 years. So it's better to go to jail for 5 years than it is to go to jail for 10 years. And so you can see you will think the same thing because the game is symmetrical. Yeah. And the solution that we will arrive is that we both confess. And that's the Nash equilibrium. We don't have an incentive to deviate from that strategy, given the other strategy. But then you sum up the number of years that we have total, both of us. And so you see, oh, well, between us, we will share 10 years, both of us. And then the other two solutions of one confessing or silence, also 10 years. But it's a better solution collectively, which is silence. And we call this the competitive solution, which is the Nash equilibrium, and the cooperative solution, for which we will never arrive. Sorry. That was my timer for the time. And You see, okay, wouldn't they be able to agree on going silent? No, they are separated, and that's the whole point. There's no information translation there, and that's it.
Yeah. That's the dominant solution, right? So the benefit that we have, because I think this is as we get through the conversation today, I think this is something that I want to kind of pin on the wall, so to speak, is this idea is that if you can watch what's going on, if you're watching the game and you're looking at the players and you understand the outcomes and you understand their choices, you can help to drive the dominant strategy, a strategy that makes sense for the players, so to speak, for everyone, so to speak. You can define the equilibrium point. And so let me pause there,
Yes.
because then I want to transition then and say, this is exciting and as fun as it is. And I went out when I was doing my research, I found some articles about Amazon and Walmart. And I found articles about big organizations that had applied or are applying this theory. And then I went and talked to some colleagues that work in data science, and they all kind of had some of the same thoughts. You shared this with me earlier as well. It's like, you know what, Adrian, actually, we don't use it enough. Maybe it isn't used enough in data science, and that surprised me, and I'm not sure why that is. Maybe do you see it in data analytics, or why don't we see it enough?
I do. Well, mainly I deal with infrastructure, so not that much. I do analysis on the infrastructure that we have, and that's where I face the problems that require, I would say, this tool. The conversations that we have are mostly technological, right? And so, how do I enable this feature? How do I make my system faster? How do I? Sometimes you have to think it from a different lens. I am actually dealing with people. These people have behaviors, and that's the game that we're dealing with. And since the prisoner's dilemma is all it is, it's just an analogy of situations in which agents and the solution is competing. You can translate that into the problems that we have in infrastructure, because we have a lot of players coming in and doing something in a system that is shared. And then, since they are not aware of each other, the solution that we end up arriving to is not the optimal. I'm thinking specifically, for example, in the problem that we have right now in Globo, which is the traffic that we receive in Starburst. When you think in this way, it's, well, a player is doing a query in our system, and that will have an impact in the queries of other users. So long as the queue grows and grows, the time of the runtime of the queries grow, that will essentially become a prisoner's dilemma. If I choose the egoistical solution, which is I just do queries, I don't care if the system explodes, then the system explodes. It's a self-fulfilling prophecy. If I choose the cooperative solution, other people will choose the competitive solution and they will have their queries run, and I won't. So essentially, I will go to the Nash equilibrium and I will execute my queries, and then the system explodes. And so this requires that you do the analogy like, okay, if it's the same problem, what is the solution to the generic problem? Right? Because what I have is, I have management asking for more optimal solutions in the space of what we call the holy trinity of infrastructure, which is cost, efficiency, and resiliency. And if you want to talk about that, what that means in a clear example is cost in our Starbucks environment means that I pay more or less for machines and I pay more or less for license. Efficiency means that the system responds better, which means that a query is faster, and resiliency means less or more errors. And each of these axes is tied to the other. Any solution that I can propose essentially pulls one way or another. If I want to be more resilient, I either have to be less efficient or I have to spend more. If I want to be more efficient, I probably will be less resilient or I will spend more. If I want to spend less, I will have to be less efficient or I will have to be less resilient, or both, a combination of both. So they're essentially the same thing. And what I see is, okay, any technological solution that I can apply in that space can be complemented with behavioral solutions, which are the domain of game theory, because the problem is the same. Traffic problem is the same as the prisoner's dilemma, because it's people competing for resources. It's just that. And so, yeah, we can go into solutions.
Let me play it back a little bit, because when we said, hey, we don't use it enough in analytics, what I'm hearing now is maybe we use it quite a bit on the data analytics side, but we don't use it enough on the data engineering side. That's what you're saying is like there's actually a broader application. And so maybe data scientists think that theory belongs to us. Yeah, maybe economists would say that theory belongs to us. We apply this game theory to economic problems. We apply this theory to analytics problems, competitive pricing problems, competitive product problems. And you're saying, hey, hold on a second, I might just be a data engineer, but I can take the same concept and I can apply it to trying to balance this notion of resiliency, cost, and performance, right? That have a complex set of players all trying to make decisions for themselves, prisoner's dilemma, that may or may not help the other players in the team, so to speak. And so if I go in there and I want to do everything for me, I could increase costs or affect performance for other teams. And let me add something there, because I think, and correct me if I'm wrong, but when I look at that problem, I think that problem was worse before, when I was looking at these big monolithic centralized data warehouses or data architectures where I had everything in one place. Now that problem is massive, because any little thing I want to do, I've got limited resources to model data. I've got limited resources to ingest data. I've got limited resources to drive consumption of data on the front end. And so truly a dilemma, right? Maybe you feel like a prisoner because you're working in a very tight environment, right? And so fast forward to what we're doing now here with Glovo, I think, and you're looking at a more federated environment. You've got more options where you've got the ability to scale up and down. And so you're not scaled all the way up when you don't need it. So you can bring costs down. You're scaled at the right level. Different teams maybe have access to do different levels of compute without having to build their own infrastructure and so forth. And so you have more options, but now you've taken it a level up. You're like, great, I have more options, but we can still do better if we set the right framework. How do you set that framework?
So if we go back to the prisoner's dilemma and derive from there the solution, what is the main problem on cooperativeness? Like, why don't players choose to cooperate? Why can I not lower my traffic by making my users talk to each other? In the prisoner's dilemma, it's because each prisoner is in his own room and they cannot communicate to the other their intentions. Hey, I'm gonna stay silent. Why don't you stay silent? Even if they could, in the pure form, would it be credible? But that's another problem. But you can abstract this communication as information. And so what we want to do with the system that we manage is, okay, how do we make users communicate with each other to self-regulate the usage? Because what you want to do is you take the game in which you have rewards and costs, and you want to modify that in such a way that it incentivizes users to choose the best cooperative solution. And so, okay, what is that reward? What is that cost? And if I were to think about my team, my subdivision at some company, I would say, okay, I'm providing a service and I am not charging for the queries. So I absorb all the costs myself, and the user never gets the information that the query costs something. And so they will overuse the system because they will choose the competitive solution. My query costs nothing. There's no cost for me. So
no limit.
What should I do? I'm just gonna kill that service. Okay. What did we do? What we did was, okay, we will take our cost, our fixed cost, fixed, not in time, but it's fixed, right?
Yeah.
And I'm gonna distribute it per query using the information that you provide in the insights database per query. We devised that model. It's a very simple model of weights, saying, okay, per each hour of usage, I have this fixed cost, and each query is spending this amount of CPU. I'm gonna make that the weight of the overall CPU usage for that hour, and I'm gonna distribute the cost per each query. And then I publish that. And then I say, okay, now I'm gonna take from your budgets whatever you spend on my queries. And that makes you as a user say, okay, wait, then I cannot do whatever I want because my game has changed. Now I have a cost on using service. And it's perfectly elastic because it's per each unit that I do, per each unit that I sell, I have the cost.
Yep.
And then it should come as a given that you could modify the model to accommodate and make the traffic fluctuate. I could balance the price in such a way that peak hours are more expensive and valet hours are cheaper, and then you would flatten the traffic. People would move to the cheaper parts, and then they would move away from the peaks of usage. So I would be able to provision a stable number of workers there, theoretically. This is all theory. The reality is that let me put something in between. If I were to model this price dilemma into a traffic problem,
Uh-huh.
the solution would be if it were a road, this would be the same as putting a toll booth. And there's an assumption there that you looking from above of the game can exact the price of the toll. You are the government and you have the power, you have the force to impose that tax or price on the users. My team, what is lacking is the power to impose. So right now, the model that we have is informative, but no budget is being taken care of. So in that trinity where management asks for better solutions, more optimal solutions, the conversation I have to have is not, hey, this is the technical solution I'm going to add. No, it's, I need you to back me up in this new solution, which is, I will give you at the end of the month a bill for each department, and you will take from each, because you are the government. Procurement finance is the government. You will take the money and you will balance out whatever budget I ask you for our service with what we are earning. And then we will have a proper conversation on that, because it's not only technical, it's also behavioral. Hey, we need to model the behavior of our users properly. Otherwise, you're cornering me in trying to optimize the 3 points of the Trinity without the tools. I'm getting the cost,
Yeah.
I'm getting the problem of efficiency, I'm getting the resiliency cost, and I get nothing in return because I'm not charging anyone, and everyone can enter. It's so the system is going to be overused anyway because it's the Nash equilibrium. It's the obvious outcome.
Let me play it back. So if we understand game theory and we appreciate the concepts, as a data engineer, I'm watching the game play out every day. This game is playing out every day as my customers, whether they're data scientists or whether they're BI dashboard teams, or they're fighting it out, so to speak, right? They're all trying to drive, in many cases, very different outcomes, but they're living within the same ecosystem, living in the same environment. So as a data engineer, trying to balance that holy trinity of cost, performance, and resiliency, I need to create a framework that's going to drive the right behaviors. Love it. Love it. And you know, what's interesting is I'll contrast that, because what you described, it's very hard to do. And I think it's easier today. Let me just, my experience, right? So, you know, I was driving chargeback in an old organization, IT chargeback, for $2 billion worth of IT cost, right? And in that chargeback model, for specific data project teams, they were trying to drive something forward, right? We had an agile framework, so it was all about small MVPs, but nonetheless, when I was doing my chargeback, it was project resources, it was storage resources, it was data engineers. Every project had a level of ingestion, a level of storage, a level of modeling, and it was a lot of work. And so those chargebacks were big chunks, right? And they weren't fast, so to speak. What you're describing is so much simpler, right? It's like, hold on a second. In my new model, I had teams, I've given you the ability to create your own queries, right? So you don't have to go move data anymore. You can query it. So I made that easier. In this new model, I've given you the ability to, maybe reuse data products. So maybe sometimes you don't have to re-ingest data. So I've made a lot of things simpler. But because I've made it simpler, I've also maybe created more demand. And now everybody wants to run. It's like, great, you're punishing me because I've made a simpler model. I've given you the ability to query your own. I've given you the ability to create data products. But now you can overload the system. And so we have to be careful in this new system, which works. If I can create greater transparency for what's really going on, make sure you understand the price per query, which is easy, because if it's just query cost, compute cost, they don't have to worry about anything else, right? All they're worried about is that compute cost. It's fantastic, right? They can make their own decisions as to whether or not that's something that's, and to be fair, because it's not a very high compute cost, you might decide to introduce other factors, right? Because somebody might say, oh, that's really cheap, I'm going to run it all day long. And maybe you would say, that's not the behavior I'm trying to drive. So you probably have other governance rules in place as well to kind of keep people in line.
If I were a good businessman, I wouldn't only include the cost, I would do a markup, because that's how companies operate, right? So I would say, okay, I have my costs, which are my fixed costs. It's basically everything that is AWS, everything that is licensed, and everything that is human time.
Yeah.
I'm only charging you for license and AWS. I should do a markup to cover for the fixed cost that I cannot distribute, which is the people conforming the team, because I cannot. How do I do human hours per query? It's a very complex model. If I could do that, I would be working HR and making millions, basically. It's a hard problem. But what I want to do is, I don't want to be the central decisor. I don't want to have to think about what to provision every day and predict the usage. It's a very erratic behavior. It was during the night we have spikes. During the day we have some flat times on traffic. But then, how do I predict that? I could do machine learning, but how accurate would that be? Why don't we do this in another way? Instead of having one brain thinking about this centralized, we decentralize the computation in everyone's mind by communicating through prices.
Yeah.
This is tied up. We could talk about data mesh, because data mesh is basically the same. It's like it's a comparison between capitalism and socialism in a way. What happened at some point in history is that, okay, some people thought maybe we should have societies in which we don't have a market, but someone centrally decides the procurement of every asset and good for an entire economy unilaterally. And then we say, this is what we need. This is the price that we will need for this city for this day. Imagine having to compute that for every good in an economy. It overloads you the same way it overloads my team. No. I'm going to distribute the computation into the human hive brain. You are going to take the decision through game theory. It's not game theory, it's behavior, because I give you the information to make the decision, which is the price, which is your reward and your cost. That's it. I have a distributed computation engine out there, which is my users. They make the decisions themselves by creating the framework.
Love it. I'm going to try to summarize some of these big things back, so close up a little bit. And I wanted you to challenge me if I've misunderstood it, but I want to bring it back together just so that for the audience can kind of take away the key points. I think first and foremost, we started talking about game theory as a concept, and it's fun to talk about. Watch the movie, but even like I said, this is an economic theory that goes back 100 years before the movie probably, and so it certainly has some historical significance. But if you understand the concepts there, and you understand the basic notion that we're working within tight ecosystems with many players that are oftentimes fighting for some of the same resources, making decisions that affect each other, then we can fast forward and say, well, we already seen that applied to big data analytics and big organizations where you're dealing with a lot of market competition and you want to make sure that you're making the best decision, but also considering how your decision will affect others and what they may come back with, right? And so that's a fantastic application of game theory and data analytics. You've come forward today and said, yeah, Adrian, I get all that. I love it. Yeah, but I'm a data engineer.
It's everywhere, actually.
And I think we should use it more in the day-to-day life of a data engineer, right? And then you've come forward and said, let me give you an example. I'm trying to manage this holy trinity every day, right? Cost, performance, and resiliency. And I'm trying to do that in the most effective way for my customers. I want to give them all low cost. I want to give them all high performance. I want everything they do to be highly resilient. But I can't do that for everybody at the same time. We've got to find a way to manage the ecosystem. And so you've come forward and said, I can apply the same notion of game theory to what they're doing by applying a framework, right? Top-down approach, right? Maybe it's more of a socialistic approach, but it's a good concept, right? It's like top-down approach. I can control the market if I'm transparent with pricing, right? And some nuances there that I want to underscore is that the reason that I can control pricing is because I'm only having to manage a very simple. So in the old days, whenever I would charge back, I would have to consider this huge list of things I was charging back. In a modern data architecture, I'm leveraging data where it sits. And so I'm really just focused on the cost of the query And even if it is a low cost query, it still has a cost. And if everybody queries at the same time, even though I've got a highly performant system that's going to scale up, I need to be able to manage that, right? If I said to everybody go because it's cheap and it's unlimited, that's not good for anybody, right? So there's always an opportunity to balance. You've created a framework that allows you to balance these simple variables, the cost, the compute, so to speak, that I think enables your customers to make better decisions. So ultimately, do we call that an Nash equilibrium? I don't know what we call that, but the dominant strategy is that if we manage this accordingly, everybody's getting the right level of cost at their performance, so to speak, ultimately with good resilience across the board, right? And I think
we're getting a more optimal solution. Yeah.
What's most important for your organization? Is it cost, resilience, or performance? It's a trick question.
It's a trap question because
it depends.
What I hear is all of
yeah.
This is the main problem, that no one wants to choose. Everyone wants everything. Not choosing means also choosing. It's no, not each of a. None of them is more important than the other. Okay, so everything is important. What do I focus on?
And the reason I asked that question, the reason I want to close that question is because I think it's a really important point. In my old, history, so I remember being brought forth. I had a business I dealt with that always had the money, right? And they'd come in and say, "I don't care what it costs, just get it done fast." Boom. And so then I would take all my resources and I would go apply it to that project, and then all my other business teams were like, "Well, you don't have any more project resources now. We got a backlog." Yeah, but I need people. Yeah, but this project's really important. And so if you want more people, it's going to be a higher cost. I got to go to contractors now. And so we made one decision for one business team to go get their project done because they were willing to pay for it up front, and it affected everybody else. And everybody else's cost increased, and everybody else had to wait. And that was because I only had one system to work with. This is really important, I think, is when we think about a distributed, you talked about data mesh, right? A federated framework. That's not the case anymore, right? If you do get one project team that comes to you and says, "Look, Gerardo, we got to go now. I don't care what it costs. I need high performance and high resiliency." You can say, "Okay, no problem. I'm going to dedicate you a cluster, and you're going to pay for that cluster, and you're not going to affect, and nothing that you're doing there is going to affect anybody else." That's an incredible option, an incredible capability to have, I think. Yeah.
You answer for the cost. I don't. Perfect. We give you others. I can focus on efficiency and resiliency for you. Perfect.
Right.
If I have to focus on the three at the same time, that's when the real problem arises. It's like the actual, that's a fun problem. How to balance the right way.
Yeah.
Where is the right? And so the thing is, okay, I can play in that space, triangle space, or I can go up to different spaces if I apply solutions that are not technical, by making my players behave better.
Gerardo, as to close, I see the drum set behind you, man. Give us a riff or something. No, I'm not.
I don't think you want to hear this thing. It's
just
for concerts, so
a little
loud.
bit of, I don't know, AC/DC something. No, I'm joking. No, I'm just. It's okay. I really appreciate the conversation today. This is a different type of discussion because we went from this conceptual notion of game theory to how it's applied to data analytics, and we really brought it to bear. So we really brought the focus on data engineering, which I think is a very unique approach. Thank you for bringing that to us. I appreciate it.
Thank you so much for the space.
All right. Thank you. Good show.
Thank you.